Let's be honest. Have you ever looked at a system of linear equations and just felt overwhelmed? You've got x's, y's, plus signs, equal signs, all kind of jumbled on the page. It can get messy fast. Well, today, we're going to learn this incredibly clean, super powerful way to just slice right through all that clutter. We're going to solve the puzzle.
So here's how we're going to do it. First, we'll look at the cluttered problem we're all used to. Then, I'll introduce you to the hero of our story, the matrix. After that, we need to know where we're going, so we'll define our destination. Then we'll learn the rules of the game. And finally, we get to put it all together and actually solve the puzzle. It's going to be great.
All right, part one. Let's start on some familiar ground, right? Let's look at the exact kind of problem we're trying to make easier.
Okay, so here we have a classic system. 2 equations, 2 variables. Now, you could absolutely solve this with substitution or elimination. And you know what? For a small one like this, that's fine. But what happens when you have 3 equations, or 4, or 10? It becomes a nightmare of rewriting, and it's just so easy to drop a minus sign or make one tiny mistake that throws the whole thing off. So you have to wonder, right? Looking at this system on the left, isn't there a better way? A more organized, more streamlined way to just deal with the important numbers and get straight to the point, without all the extra symbols getting in the way?
Well, the answer to that question is a huge, resounding yes. And that brings us to part 2, where we get to meet the truly elegant solution to all our clutter problems.
Just look at that transformation. On the right, that's what we call an augmented matrix. What we've done is strip away all the extra stuff, the x's, the y's, the equal signs, and we've just arranged the numbers, the coefficients, and the constants into this simple, clean grid. See? The first column is for x, the second for y, and that line is basically our equal sign. It's all the same information, just beautifully organized.
And that's the formal definition right there. An augmented matrix is just a way to capture the essential numbers, the coefficients and the constants from our system of equations. This is our new clean slate. This is our game board.
Okay, so we've got our starting point, our game board is set up. But, in any game, you can't play if you don't know how to win. So before we even learn the moves, let's take a look at our destination. What does the finish line look like?
This right here, this is our prime directive. The whole point of the game is to transform the left side of our matrix, the part with the coefficients, into this very specific, very simple form. It's called the identity matrix. And this is what we're aiming for. This is the goal. We're going to manipulate our matrix until the left side looks exactly like this, a diagonal of 1s and 0s everywhere else. Now, here's the magic. Once we get it to look like this, the numbers that pop out on the right side, that is our solution. The top number will be x, the bottom number will be y. The answer just reveals itself. No more work needed.
And this solved state, this finish line, it has a fancy official name, reduced row echelon form. It sounds a little intimidating, I know, but just think of it as the winner's circle, where the answer to our puzzle is just sitting there, waiting for us in plain sight.
So, we know where we're starting, and we know where we're going. The big question is, how do we get from point A to point B? Well, let's go over the rules of the game. Turns out, there are only 3 legal moves we're allowed to make.
And there they are. That's it. This is our entire toolkit. These 3 simple actions are called elementary row operations. You can swap any 2 rows, you can multiply a whole row by some number as long as it's not 0, and you can add a multiple of one row to another row. With just these 3 moves, we can solve any of these puzzles.
All right, it's time for the main event. We've got our starting matrix, we know our goal, and we have our 3 rules. Let's play the game. Let's solve this thing, step by step.
Okay, here's our game board again, the very same augmented matrix we built a minute ago. Now, our first strategic goal is to turn that 3 in the bottom left into a 0. So, how can we do that with our 3 rules?
We're going to use rule number 3. We're going to add a multiple of one row to another. So to turn that 3 into a 0, we can use the one right above it. Let's multiply the top row by -3 and then add it to the bottom row. So let's do it piece by piece. For the first column, -3 times 1 is -3, plus 3 is 0. Perfect, that's what we wanted. Second column, -3 times 2 is -6, plus 4 is -2. And for the constants, -3 times 5 is -15, plus 9 is -6. And boom, step 1 is done, we have our first 0.
Okay, next move. We want a 1 where that -2 is sitting. And for this, we'll use rule number 2.
multiply our row by a non-zero number. The perfect number here is -1/2, because -2 times -1/2 is +1. So let's multiply that entire bottom row. 0 times anything is still 0, which is great. We didn't mess up the 0 we just worked for. -2 times -1/2 gives us our target 1, and -6 times -1/2 gives us a +3. Just look at that. We are so close to the finish line.
One last move to win the game. We need to turn that 2 in the top row into a 0. We're going to use Rule 3 again, using the 1 in the second row to cancel it out. Let's multiply the second row by -2 and add it to the first row. Ready? First column, -2 times 0 is 0, plus 1 is still 1. Awesome. Second column, -2 times 1 is -2, plus 2 gives us the 0 we needed. And finally, for the constants, -2 times 3 is -6, plus 5 gives us -1. And that's it. Look, the identity matrix is on the left. We did it. We've reached our destination.
So what does this beautiful final matrix actually tell us? Well, remember, the top row is our x equation. It says 1 times x plus 0 times y equals -1. In other words, x equals -1. The second row says 0 times x plus 1 times y equals 3, or simply y equals 3. The solution is right there, clear as day. No more algebra, no more substitution, just the answer.
So let's do a quick recap. We took a kind of messy, cluttered system of equations and we organized it into a nice, clean, augmented matrix. We used just 3 simple rules, our row operations, to strategically transform that matrix. Our goal was that clean, simple, reduced row echelon form. And by doing all that, we turned a complicated problem into an elegant, totally obvious solution.
You know, this whole process is really more than just a math trick. It's a way of thinking. It's about taking something that looks really complex, finding a better way to represent it, and then applying a simple set of rules to find a clear answer. Which kind of leaves me with one final thought for you. What other complex problems, maybe in your work or just in your life, could be totally simplified just by changing the way you decide to look at them?